All right, welcome to today's Explainer. Today, we are diving into what you might call a totally unexpected tech empire. We're looking at a company that literally started out 30 years ago just making parts for video games, but has somehow maneuvered its way into becoming the absolute central pillar of modern society. And for sure, the dominant force in generative AI. It is genuinely fascinating to trace how a 90s gaming hardware company evolved into the backbone of the most advanced computing on the planet. I'm talking, of course, about NVIDIA. So let's jump right in and unlock this mystery together. 530 trillion yen. I mean, it's a number with so many zeros that your brain almost doesn't even want to compute it at first glance. But this astronomical figure was actually their valuation this past June. And what's really incredible here isn't just the sheer size of the number, but the lightning-fast speed at which their stock soared to reach it. In a relatively tiny window of time, this valuation allowed them to briefly surge past established titans. We're talking Apple and Microsoft, placing them squarely at the #1 spot as the most valuable company in the entire world. It's a scale of wealth that fundamentally reshapes the entire tech hierarchy. To really wrap our heads around just how big that is, let's think about Toyota for a second. Toyota sits at a market cap of roughly 50 trillion yen. That is Japan's absolute biggest company, right? A massive physical manufacturing titan with global infrastructure, factories, and supply chains spanning the whole planet. And yet, this hardware tech company manages to eclipse it by a jaw-dropping 10 times difference. When you compare a legacy automotive giant to a computing company, it really puts the sheer momentum of today's tech sector into perspective. Just thinking about this massive disparity naturally begs the question, how in the world did they achieve this unprecedented growth? Well, that brings us to Section 1, Supermen versus the Army. Okay, so a really helpful way to think about this fundamental hardware difference is through a simple analogy. Imagine your standard computer brain, the CPU, as one elite Superman. This guy is an absolute genius at handling complex tasks one by one, maybe juggling around 20 operations flawlessly at once. But a GPU, which is exactly what NVIDIA specializes in, is an entirely different beast. It's more like an army of 10,000 soldiers. Individually, they aren't Superman, but through sheer force of numbers, they can execute simple tasks simultaneously. Think about playing a video game. You have to paint millions of pixels on a screen all at once, over and over and over again. That intense demand for parallel processing is the exact reason GPUs were built in the first place. Let's see how that core technology plays out over time in Section 2, 3 Waves of Revolution. Tracing their journey is actually a wild story. CEO Jensen Huang and 2 friends founded the company back in 1993 to tackle the exact image processing tasks that those CPU supermen struggled with. And it is so fascinating how this single focus allowed them to catch 3 massive technological waves. First up, their tech perfectly matched the 3D graphics boom of the 2000s as video games started getting incredibly visually demanding. Then they struck absolute gold in the 2010s crypto mining era, basically because crypto mining relies on repetitive hashing math, which is the exact kind of parallel processing GPUs excel at. And now, they sit right at the center of the generative AI revolution of the 2020s. It is just a remarkable timeline of being perfectly positioned for completely different eras. But you might be wondering, why is this specific hardware so absolutely crucial for AI? Well, to create a smart AI like ChatGPT, you have to use a process called deep learning, which essentially feeds the AI massive amounts of data to learn from. So for example, if you want to teach an AI what a cat looks like, you have to feed it millions of images and have it analyze them all simultaneously. You literally cannot do that efficiently with a single Superman CPU. You absolutely require the parallel processing approach of that 10,000 soldier GPU army to handle millions of calculations all at the exact same time. And as you can imagine, this creates a wildly intense demand. 5 million yen. That is the cost of just one single specialized H chip from NVIDIA. But here's the thing. The tech companies building today's AI aren't just buying one of these. They are eagerly buying thousands of them. They are stacking them into massive server racks, fighting through huge logistical bottlenecks, and spending billions of yen just to secure the raw hardware needed to train their models. This scramble to acquire these chips has effectively turned them into the single most sought-after commodity in the tech world right now. But hardware is only half the story. Let's look at Section 3, the software trap. Now, to understand their absolute secret weapon, we have to travel back in time a bit to 2007, and it involves a brilliantly strategic, almost Trojan horse kind of move. Jensen Huang created a software platform called CUDA. You see, before CUDA, programming a GPU for anything other than gaming was incredibly painful. You basically had to trick the graphics hardware into doing standard math. CUDA changed the game entirely. It created a universal language that allowed developers to easily program NVIDIA GPUs for general computing. And the pivotal decision? They released it completely for free. But they went way beyond just giving the software away. NVIDIA actively built an entire academic ecosystem around it. They aggressively donated GPUs to universities, they funded extensive research, and they thoroughly trained university students on exactly how to use CUDA. By doing this, they essentially made their platform the academic standard. They raised a whole generation of engineers who grew up knowing exactly how to use NVIDIA tools. And, eventually, those students graduated and entered the workforce, taking that very specific, heavily ingrained skill set right with them into the world's biggest tech companies. Because they established this foundation years ago, NVIDIA now holds a frankly laughable, overwhelming 90% share of the AI chip market. And the reason is super simple. Apps built with CUDA only run on NVIDIA GPUs. This creates an incredibly deep software moat. Even if a competitor, say AMD or Intel, releases a cheaper or maybe even slightly faster AI chip tomorrow, companies can't just easily switch. If they did, their entire engineering team would have to completely relearn a brand new set of development tools totally from scratch. It takes way too much time and money, leaving developers completely locked into the NVIDIA ecosystem. Okay, let's bring this down to a personal scale with Section 4, AI on your desk. We've been talking a lot about massive billion-yen servers and total global tech dominance, but let's abruptly shift the focus right down to your own personal desk. If you have a PC right now with an RTX 4000 series GPU, you already have access to some incredibly powerful tools for free, like NVIDIA Broadcast. It's honestly like magic. Imagine you're a remote worker giving a presentation. Even if you are actively looking down at your notes, the AI naturally corrects your gaze so it looks like you are maintaining perfect eye contact with the camera. Or, if a dog starts barking in the next room, it intelligently isolates and cancels out just that background noise. It completely upgrades the workflow for creators and remote workers alike. Now, you've probably been hearing the buzzword AI PC thrown around a lot lately, right? These PCs use a chip called an NPU, or Neural Processing Unit, which is now being built into newer standard computer processors just to handle basic AI tasks. But tests show that an NPU only has about 1/5 the processing power of a dedicated NVIDIA RTX GPU. To put that into perspective, if an NPU is like taking a brisk walk, having a dedicated RTX GPU is like driving a sports car. When it comes to the real-time speed and quality of running local AI apps, that dedicated hardware just puts you in a completely different dimension. And they are pushing these boundaries even further with tools like Chat with RTX. This actually lets you run a highly capable AI entirely on your own computer, 100% offline. Think about why this matters so much right now. One of the single biggest fears in the corporate world is accidentally leaking proprietary data to cloud-based AIs like ChatGPT. Well, with this offline capability, an enterprise could safely feed the AI 10 years' worth of highly confidential company data and have it analyze everything without any fear of that information ever touching the internet. It provides complete, secure control. There is absolutely no doubt that artificial intelligence is going to be the core engine of our future. When we set out to understand this massive 530 trillion yen mystery, it really all boils down to this incredible journey. From building a 10,000 soldier army just to run video games, to standardizing the entire industry with their free CUDA software, right down to putting immense, totally secure AI power directly onto our own desks. So as we wrap up this explainer, I want to leave you with this final thought. When you realize the incredible parallel processing power that is sitting right there in your home or office, how will you command your personal GPU army to create the future?